Today we'll learn how to identify and predict three different types of reactions: combination reactions, decomposition reactions, and single replacement reactions. First, combination reactions have, in this class, two elements combining to form one compound. But later in other classes, maybe compounds can also combine to form compounds. So, first we have, as an example, aluminum reacts with chlorine gas. All right, so you want to be able to predict the reaction by writing out the formulas of aluminum and chlorine gas. So aluminum is on the periodic table, it's Al, and chlorine is Cl. But you don't want to write it as Cl here, but Cl2. Chlorine is a diatomic element. These are memorized things for you. When you see these elements on the periodic table in this order, then those will be diatomic elements. If they're by themselves, if they're a pure element of that, but not stuck to some other element, then they're going to have two atoms stuck to each other. So this is two hydrogen atoms stuck to each other, so we write H2. It can be easy to memorize these if you just remember the term Brinkelhoff for bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Or just remember that they're in this order on the periodic table. It's sort of like an L. So we write Cl2 as the chlorine reactant. And then we want to predict the products of this reaction. Yes, the reactants are on the left side and the products are on the right side of this equation. But in the middle is this arrow, which means yields or gives or results in. So to predict what we get when we combine aluminum and chlorine, we want to consider the only compound that could form when we combine aluminum and chlorine. Now aluminum has a 3+ charge if it has a charge, and chlorine, when it becomes chloride, it gets a -1 charge. So in order to balance the 3+, you need 3 -1 chlorides to balance that. So crisscross, it's AlCl3. All right, so we've written the reactants and products, but we have not yet balanced this equation. We want to make sure that we have the same number of atoms of aluminum and chlorine on both sides. That's because atoms are not created or destroyed. They're only rearranged. You know, the chlorine atoms were bound to each other originally, but now they're going to be stuck to aluminum. But there's still going to be just as many chlorine atoms before and after. So to balance the overall equation and make sure we have equal numbers of atoms on both sides, we can only change the coefficients, the numbers in front of these formulas. Now, originally, these might all be nothing or 1. But to make sure that we have enough of each thing, we might say, oh, there was only 1 aluminum at first, and when there was not a 3 here, there was only 1 Cl2, and hence there were 2 Cls on the left. And on the right, when we had only 1 AlCl3, there was 1 Al and 3 Cls. So we would have been initially balanced in aluminum, 1 aluminum on both sides, but we would not be balanced in chlorine. There'd be 2 on the left and 3 on the right. So to make sure we get equal numbers of chlorines on both sides, we need to find that least common multiple of 2 and 3, which is 6. You know, if you had doubled 2 and made 4, that would still not be the same as 3. So the common trick is if you see 2 and 3, you go for 6. So if you can get 6 chlorines on both sides, then a chlorine will be balanced. So put a 3 in front of Cl2. Now there's going to be 3 times 2, 6 chlorines. So cross out that old 2, put in a 6. And if you put 2 in front of AlCl3, now there's going to be 2 times 3, or 6 Cls. Now chlorine is balanced. But by changing these numbers in front of the entire compounds, that will also change the number of aluminum atoms. There was 1, but now we have 2 entire AlCl3s. And so now there's going to be 2 times 1, 2 aluminums on the product, So to balance that, put a 2 in front of the Al here so that we get now 2 aluminums on the left. Yeah, again, to balance, you can only change the numbers in front of these formulas. You know, if you wanted 6 chlorines, you couldn't just write 6 here. You always need to have 1 Al per 3 Cls because that's the only way that those charges balance out. And so instead of changing what the compound is and making an impossible compound, you will just change the numbers of those compounds by changing the coefficient in front. Yes, that 2 and that 3 are called coefficients. We'll see that again. All right, next question. You know, we had combination reactions where elements would combine together, but there's also decomposition reactions where the opposite happens. A compound breaks up into 2 or more elements in this class or compounds in other classes. So maybe you're told silver 1 oxide is heated. What is silver 1 oxide as your reactant? Well, silver has a +1 charge and oxide has a 2- charge, so crisscross, that's Ag2O. So you start out with that and then it's heated. So you can show that by putting a triangle over the arrow. Triangle, or delta, means change, like a change in temperature. So all that you can know is that you had one compound and it should break up into its elements. So pure silver, pure oxygen at the end. So Ag is a metal and not a diatomic element, so you just write Ag. But oxygen, remember, is a diatomic element. If it's going to be by itself, then there should be 2 of them. So you'll get Ag and O2 as your products. To balance the reaction, initially you have 2 silvers and 1 oxygen, and initially you have 1 silver and 2 oxygens. Now you want to change the coefficients so that you have the same number of oxygens on both sides. So put a 2 in front of this entire silver oxide compound so that you'll get 2 oxygens. 2 times 1 is 2. But also, this is going to change the number of silver atoms. Each Ag2O had 2 silvers, but now you have 2 of them, so you have 2 times 2, or 4 silver atoms. So to make sure that you have the same number of silver atoms on the other side, put a 4 in front there, and now, boom, there you are.